Okay. Experiment 4, exploring the mole, Dr. Memari. This experiment, we are performing the experiment on behalf of you in the lab at Central Campus, Broward College, to make sure that you can turn in your report, because you're not here to perform the experiment yourself. That's probably why you're watching this video. The design of this experiment, when I wrote this experiment, my idea was to make sure students, they know mole very well, and making sure that they can convert from mole to mass, mass to mole, mole to particles. They can find the number of moles using a solid compound. They can find the number of moles using a solution. Solid, I meant by solid is just a pure sample. It could be liquid or solid. If you have the mass of the pure sample, or if you have concentration of the solute in a solution, you should be able to calculate the mole. And when you have the mole, you have a periodic table, you multiply mole by molar mass to get the mass of the sample. If you have the moles, you multiply it by Avogadro's number to get the number of particles. And then it depends on what particles you're talking about. So if you have mole of H2O, you want particles of H2O, you just multiply by Avogadro's number. If you have moles of H2O, you want to find the particles of hydrogen, then there's factor of 2 also that you have to apply. So you find the particles of H2O, how many molecules of H2O you have, then for every H2O you have 2 hydrogens, then you multiply by 2 again, 2H over 1 H2O ratio to get the number of particles of hydrogen. If you have the moles, you can find the mass, you can find the particles also. The experiment is designed for you to get the data with different stations, and when you have the data for different stations, then you do your calculation following the procedure. When you look at the experimental procedure, you have to go station to station. So if you were in the lab, you would see these stations, but those stations are going to be like more spread around in the lab. I have all 14 of them probably here on this bench. They put it for me. But for you, you just walk around the lab and you record those numbers. Anytime that it requires a number or measurement, you do the measurement, and if it's number for you to record it, then you are going to record it. So, station 1. What's on station 1? It says in this station we have a piece of glass as the size of the microscope slide, and we want to measure the mass for you to record the mass. So you are going to place that on the scale, making sure that scale is turned to 0. So I'm going to focus on that. 0. Place the slide glass on the balance pan. Record the number. That number, not sure you see or not, but I'm going to record that number for you. Here, station 1. 9.094 for gram. So that's your station 1. Station 2, it doesn't have the actual measurement here because it's giving you the piece of is a compound that is found in the cocoa plant, and you have enough information to do the calculation for your what you're looking for. So it's just to solve and to find the calculation. No physical measurement is needed for station 2. So station 2 doesn't have physical measurement. Station 3, we have 35 milliliters of water in the in graduate cylinder. So we have exactly 35 milliliters here. I have to be at my eye level. So we are going to record that number for station 3. Station 3 is going to be water, 35.0 milliliter. And you are going to use the density to convert the volume to mass for station 3. Station 4, we have a piece of chalk. So we have piece of chalk, which is calcium carbonate. The chalk is calcium carbonate. The mass of this chalk probably is different what is written here, but we want to know moles of the chalk first. And for this one, we have to measure the mass of the chalk. So 0, going to give you the mass of the chalk by measuring the chalk. Okay. That's 3.164. Station 4. Station 4 is 3.166. Or it keeps changing. Station 4 is 3.164 gram. Station 5 is piece of copper. You need the mass for the copper in order to find the mole. So we take the copper, we place on the balance, and record the mass for station 5. Is 1.108, 1.10, it's changing, gram. So we're done with the station 5. Station 6, 1 teaspoon of salt. So we have to measure 1 teaspoon of salt. We are going to use the mass by indirect mass, measuring mass, because we have the chemicals. We don't want a chemical on the balance pen. So we have the weighing paper. We are going to press tear to tear the mass of the paper. Then we take 1 spoon of NaCl. So I'm putting 1 spoon of NaCl and measure the record the mass. This is for station 6. Station 6 is 3.351 gram salt. Okay, station 7. Station 7 probably is just the number because I don't see a setup here for station 7. Let's look at station 7. You have the number of aluminum atoms, so the information is given. You just have to do the calculation. Just show the calculation. Station 8, you have a piece of candle, and you want to know the number of hydrogen atoms for the candle. So the formula is given, C25H52 for the wax in the candle. You have the formula, and if you have the mass, you could find the number of moles for the candle. Make sure it's 0 first. You always have to double check. And that number for Station 8 is 24.915. 24.915 grams. And that is for the candle. Station 9, empty box. So for station 9, we have empty box. We have empty box. We want to find these numbers. We have 21. So it's going to be 21 times 14.5 times 9.00. Centimeter for station 9. So in this station is asking you to find the number of nitrogen molecules in the box. So how are you going to go from measurements of the box into molecules of nitrogen? First, you need to find the volume for the box. So multiply those three numbers, width times height times depth. That is going to be in cubic centimeter. Then you are going to change that to liter. Why do we have to change it to liter? Because the density is given in liters. So 1 cubic centimeter is 1 milliliter. So whatever number you have, it's equal to milliliter. In order to change to liter, you're going to divide by 1,000 to get to the liter. Then you multiply that by density, which is 1.19 gram per liter. You get the mass of air. At that point, you get the mass for air. You have the mass for air, but you don't have the mass for nitrogen. 78% of the air is nitrogen. So you are going to multiply the mass of air by 0.78 in order to get the mass of nitrogen. Now that you have the mass of nitrogen, you divide by 28, which is the molar mass for N2. You get the moles for N2. And if you have the moles for N2, then you multiply by Avogadro's number to get the nitrogen molecules. How many nitrogen molecules you have? You probably have to listen to this part a couple times to remember the steps, but that's the good thing that is recorded. You can go back and do the steps. At the end, you realize that you need the mass of the nitrogen. You can find the mass of air. You have the volume multiplied by density, but density is in liters, so you have to change the milliliter to liter for the volume of the air. Then you find the mass for air. 78% is nitrogen. Station 10. Station 10, I don't see the station setup here, so it says no numerical measurement needed. You just have to solve the problem. So it's the theoretical value given information. So for station 10, you have the information given to you. For station 11, you have 33 milliliters of rubbing alcohol. So you have the rubbing alcohol here, 23.0 milliliters. That's for station 11. 23.0 milliliter of the alcohol for station 11. You also have the density. You have the density for alcohol. D equals 0.786 gram per milliliter. So in order to find the mass for alcohol, you are going to multiply volume by density again. So we are done with station 11. Now station 12. Station 12 is baking soda, and we want to know the mass for 1 teaspoon of baking soda. Let's go back to the scale because we have one scale set up here for us. For scale, and we are going to measure by, again, the indirectly. Place the vein paper on the scale. We place the vein paper on the scale. Press here to get the 0. Then we are going to take 1 spoon, is a teaspoon, of baking soda. Measure the mass. And that was station 12. 3.848. Sorry, 2.848. 2.848 gram is station 12. That's for station 12. So you have the chemical formula, you have the mass, you can find the molar mass using the chemical formula, then you can find the moles. Station 13, find the station 13. Okay. For station 13, you want to find the table. We have the table salt. Going to measure 6 grams of table salt. We're going to measure 6 grams of table salt. And then we are going to make 100 milliliters of solution using 6 grams of table salt. So back to the balance area. To make the solution. So I need 6 grams of salt. Tare. Wait until it's 0. Add enough to get it 6 grams. Okay. So we have 6.00 keeps moving 9 grams of NaCl. We're going to add to graduate cylinder. Add about 50 milliliters of water. Always dissolve it first before we raise to the volume. we have 100 milliliter of the solution with 6 grams of salt in there, and (100 milliliter of solution). Just make sure that it's not asking for the mass of the solution. And what is the molarity of the solution? So we need the mass. The mass is going to be the percent that we are looking for. We want to find the mass volume percent mass volume. Okay. And you also find the molarity. For the molarity, you have the volume of the solution, you have the mass of the solute, which you need to find first. From the mass of solute, you find number of moles, and you have the number of moles divided by liter of the solution, which is in this case 100 milliliter or 0.1 liter, to find the molarity. Molarity is mole per liter. The station 14, for station 14, we have a solution here that is made is a 0.1 molar aqueous calcium chloride solution. So station 14 is station 14 is 0.5 mole. Capital M stands for mole per liter. 0.5 mole CO2 solution. And the volume is 400 milliliter. For station 14, and is asking you find the mass of calcium chloride. In order to find the mass of calcium chloride, you need to find number of moles of calcium chloride. If you have a solution which is mole per liter, so in order to find number of moles, mole is going to be molarity times volume in liter. So you find you have the molarity is given as a 0.5, and volume is 400 milliliters, so that's going to be 0.4 liter. So molarity times 0.4 is going to give you the number of moles. If you have the number of moles, then you can then find the mass of calcium chloride, because you can multiply by molar mass of calcium chloride. And if you want to find the particles, you start with the number of moles, and from number of moles you can find the particles by multiplying by Avogadro's number. Those are the 14 stations for experiment 4. The data is collected. You can actually do the calculation and submit the data sheet for experiment 4. There are some additional questions for that experiment. That's basically pure calculation. You are given the enough information for you to do the calculation. You don't have to be in the lab. The part that I'm performing the experiment for is the ones that we don't have the you don't have the ability to come and perform the experiment to collect data yourself. So now you have it, you can go ahead and complete your data sheet and submit it as assignment to your professor. Thank you. That's the end of experiment 4. It's more of a theory base. You have to basically do a lot of calculation, which is a good thing. You will thank me later when everyone, who's taking the lab here, they learn about so much in this lab that for the rest of semester you are set with any other calculation. Thank you again.